Hi, my name is Mario Martinez. I'm gonna be presenting the module related to the relational data warehouse logical and physical schema on behalf of the BI team at GAPS. So this module talks about this particular section in the general diagram that we showed, this part over here. So it talks about the relational data warehouse, relational database for the data warehouse. Now first, let's talk about the logical model. If we go to SVN, this is the SVN, our internal SVN repository. Under the data warehouse folder, we got design, and then on design we got a dimensional model. So that section over here is all devoted to this particular task for the modeling and the physical schema of the relational database for the data warehouse. So if we go to this folder, we're gonna see that we have several files. These files are basically the project files related to the model itself. These files were created using a tool that in one of the versions of this tool is a freeware. It's called Power. Hold on, let me open this. It's called SQL Power Architect. So that was the modeling tool that was used. It's a very good tool. That is has a version that is basically freeware and allows many things, including reverse engineering and basically generating code for different type of relational database systems. So it's a very powerful tool, and that's the tool that was used. So the models itself, the logical models, were created on this tool, and they're all accessible under this folder over here for each of the data marts related to the project itself. Each of the data schemas related to the project itself are being modeled using this tool. Alternatively, we have a folder inside that is basically the export. It's basically the same models that we have over here, but exported to PDF. That is very convenient to be able to share it. Now we go over here in the source, in this dimensional models root. We got a couple documents that are the most important documents. We got this document, a steady-cycle data warehouse physical data model document that basically is is an Excel sheet that talks about everything related to the data model design at the logical and physical levels related to the data source related to silos. The silos data source. We got two main data sources in this project: silos and AX. This project, this file talks about the data source, silos data source, and here we can see there is an index, and from this index we can basically jump to each of the different sections. For example, this part over here, the physical data model, if we go to there, we're gonna see at the physical level each of this, it's a description of each of the columns for each of the tables that are being implemented in the physical schema. This is for the dimension tables, and below in another section we're gonna be looking at the same kind of information for the fact tables, which is basically the intersection, the bridge tables that intersect the dimension tables, where the metrics, where the facts that becomes metrics are basically hosted. Besides that, we got a link to the models that I previously showed. This is basically the models that I previously showed that were developed using SQL Power Architect. And at the end we have even a section for the cube itself, which is the presentation layer, which is basically talks about the different semantic meaning of each of the metrics at the cube level. And lastly, we have a data dictionary, which is basically a description of each of the columns that we can possibly find for each of the tables. And again, this is for the columns that are not documented anywhere else. Now in the same token, we got the similar document for the data source related to AX, which is this one over here. The document has the same structure, has a section for the physical model itself, and has a section for the model, the logical model. And you notice here there is a column even to denote if the type, if there is history that we need to track related to each of the columns in each of these tables. ACD type basically means that if we need to track history for each of the tables, for each of the columns of those tables. Type 1 means that we don't need to type history, we don't need to track history. Type 2 means that we want to track history, in short. Now, the next thing that we're going to do, we're going to connect to TFS, and we're going to take the script that basically has the whole schema. It's going to install the whole schema for the data warehouse, and we're going to be installing it locally in my PC. That script lives under the team project name silos under the folder name BI. Here is where we have segregated everything related to the BI project. There is a folder named Data Warehouse DB scripts, which basically has the script that is going to create the whole, it's going to create the database and all the structure inside for the Data Warehouse relational database. Let's open this script. Let's go to my local PC. I already connected here. This is this instance of SQL Server is running right now in my local PC. I'm going to create a new database. This new database, let's call it Silos BI. And let's leave the default settings for now. Let's open a window, and let's take this script from TFS in its entirety, and let's copy it and let's paste it here, and let's run it. That's gonna create the whole structure of the relational data warehouse. Script runs fine. Let's run some tests to make sure that we created all the objects. I think we are right. We created 56 tables and 15 store procedures. So the next step in the setup of this Silos BI data warehouse, which is basically the relational data warehouse, is to basically populate the sorry, is to populate the date dimension. The date dimension is a static dimension, so it doesn't change over time. All the attributes that make up this dimension are static by nature. They don't change over time. We just basically add as needed. So I'm gonna create the date dimension from a time range given going back to 1980s all the way to 2099. So we won't have to be concerned about missing a date here for a while. And that stored procedure is basically going to create the date dimension for this time range. We don't find. Let's try to make a test to make sure that we got everything. Let's make a count. This is the date dimension. I need to put the video here, but that's okay. So we got this number of entries, and this basically let's take a look at what we have in the shape of information that we have, and this is the information that we have. Those are the different columns of the date dimension. Notice that this calendar day key is the primary key of the table, and it's an integer. It's not a bar chart, which is very recommended to for the indexing part. This table is going to be referenced by mostly all the fact tables in the database. Here we got all possible attributes that we are going to be making use of. Now the next step is basically to create default values. So we need to have some default values in place when the ETL runs. For example, there's no value for a given dimension when we are trying to hook up a fact entry. Sometimes we don't find a value in a given dimension, and in that case we need to handle that. And the way that we handle that, we have a default value that basically is mapped, a default value in each of the dimensions, right? So the following script, basically this one over here, the one I'm gonna run right now, is the one that's gonna set those insert in default values in each of the dimensions, so that the ETL doesn't fail if there is a fact entry that doesn't have a corresponding entry in the dimension. On this, and that basically created default values for each of the dimensions that we have in the data warehouse. Let's try to do a spot check. Right here, let's pick a table. Okay, we got two records, right? In the case of the client dimension. So those are default values. For example, missing value, not applicable. Those are default values that we can use in the ETL in different areas. So after we do this, the next step is basically set up the conditions for the ETL, but technically the database is ready to be used. I mean, we have all the objects and all the preliminary setup in place. Now in the next video we're going to be talking about how to the details of the ETL and how to set up the ETL so we can be able to run it.